Hi, everyone. My name is Gerald. And welcome to JAMstack New York. So whose first time is it? Awesome, a lot of new faces. Now, who here knows what JAMstack is? So I guess a lot of you don't. So JAMstack stands for JavaScript, APIs, and Markups. And I guess it's nothing new, but it's a way to describe something, a movement towards a new decoupled web, and separating our front ends from our back ends using CI/CD, static site generators, APIs, Markdown, and using stuff like Gatsby, really popular, Hugo, React Static, and so forth. Anyone use any of those static site generators? Awesome. So tonight we're here, and our sponsors are Forestry, which is a really awesome get-back static site CMS. They have a really great product, one of the top tier ones, and we invite you all to check it out. Their website is forestry.io. Another sponsor is Netlify, which is a static site host, CI/CD, lots of APIs, developer services, CDN, etc. If you have any questions about it, I work there. Feel free to ask. And of course, we're hosted by Postlight. This is their offices. Thank you again for hosting us. They're currently hiring, so if you're looking for a job, go to postlight.com/careers. Another host is O'Reilly, and they actually gave us a 20% off if you want to buy a pass to their architecture conference. The code is dynamic20. It's right here on the screen, and if you want to know after this is over, we can give it to you later. So I also want to shout out the New Dynamic, which is a really awesome community. A lot of people who who are in the JAMstack space, who use static site generators, who are all about moving to the decoupled web and just love talking about it. This community was actually started by Bud over here, and there's a lot of articles, there's links, and there's a really amazing Slack there. I'm in it. Some of you in here are part of that Slack group, and I would love to see all of you there. Before I move on, are there any announcements? Does anyone have announcements? Anyone hiring? Just want to shout something out? Any meetups that you're all organizing? Yeah.
So I wanted
here. So everyone else.
Yes, so I just wanted to tell you all about a page that I created and put up this week. And so I've been working in e-commerce for a long time, and I'm really excited about the JAMstack, serverless, web serverless, headless, API-first world that we're entering. And I'm excited about the possibilities for the world of e-commerce. I don't know if anybody in here does anything with e-commerce. Maybe a little bit, not much. Well, if you do, check out headless.page, and I'm curating a list of modern JavaScript-based JAMstack e-commerce sites.
Thank you. That's really awesome. I think that a lot of you agree that e-commerce is a space that JAMstack needs to have a bigger footprint in. So I'm really excited about that. Thanks. I believe that you have a Meet for Performance meetup coming up.
Yeah, I can talk to it.
Okay, cool. All right, so any other announcements? All right, so tonight we have two speakers. They're Jared Short and Sergey Chernyshev. And our first speaker is going to be Jared, who's the head of developer relations at Serverless. And he's going to talk to us about building serverless API using the Serverless Framework. After that, Sergey is going to talk to us about dynamic generators. I'm really excited for this because I don't really know what he's going to talk about. But yeah, can't wait for that. So before Jared comes up, Bud's going to come up and say something.
Yep.
Hi, everyone. Thanks for being here. So this is I think our 21st meetup, and we've been meeting for a few years now. And we just went over 1,000 members of the meetup group. And So we're going to pick somebody off the attendee list and send you out. We'll message you on Meetup and that sort of thing, but we'll send you out a little swag pack of some shirts and that sort of thing from people in the Jamstack space. But I also wanted to mention the fact that, if you like this stuff, very soon, and I can't announce a date yet, but we're going to have a full-day conference coming up here in New York City. And it's going to be very soon. So I'm expecting you all to show up. So I just wanted to let you know that. So keep an eye out. Hopefully if you're in the meetup, you're keeping an eye out on the, on the mailings that we have. We also have a newsletter, the New Dynamic newsletter. If you go to the newdynamic.org, as Gerald mentioned, you can get the sign up for the newsletter and the Slack and all of that stuff. So we'll be talking about it there as well. So I just wanted to let you know, and thank you all for being here. Yep.
Like within the next month or
two, yeah, maybe like April-ish, but I can't really. Yeah, it's not like it's not set. Yeah, but close. Yeah. So all right. Thank you.
Hey.
What's that? Do you need a charger?
I'll let you know what I need to do. It's going to say demo on the screen. All right. Hi, everybody. I'm Jared Short. I'm here to tell you about the Serverless Framework, which is one of, if not the single easiest way to get an API up and running in various cloud providers. So the Serverless Framework is, clearly I work for them, and it is a framework that we built in 2015, built initially on AWS Lambda. And we're going to talk about what serverless is, what it means, how to do it, and I'm going to give, hopefully, a demo. We'll see how well that goes. But a quick about me. So I'm the head of developer relations and experience at Serverless. Prior to Serverless, I actually worked at an AWS advanced consulting company where we specialized in building serverless architectures. My first production at scale enterprise serverless application we released in 2015, and it still runs to this day. And just to give an idea of numbers and why serverless, the infrastructure and approach to architecture is so important, we were able to take something that was costing a client $500,000 to $600,000 a year to run in their own data center. We moved it to serverless, and it cost about $4,000 a month. So we were able to get tremendous scale, tremendous cost savings. Operations costs went way down, all with serverless. So what is serverless? How do you do it? So 2014, Amazon announced AWS Lambda. AWS Lambda, essentially, if you're not familiar with it, is behind the scenes a container-based technology, but you basically hand them a snippet of code, a function, whether it's Node.js or Python or Java or any more. You can run basically any language you want. I actually made LOL code run in Lambda. You can't use it, really. It's not worth using, but you can make any language you want work in Lambda. They will handle all of the server maintenance, basically operating system and down. All you have to worry about is your code, your dependencies, and up. They will handle scaling of the servers. They will handle all of the patching required on the servers. So effectively, the user doesn't really have to worry about administration or scaling, and you only pay per invocation. It's like 0.000001 cents per invocation. There might be 1 or 2 zeros on either direction missing there, but it's very, very inexpensive. So you only pay when you're actually invoking these functions, which means that if you write an API that's only called or used maybe once or twice during a day or a week or a month, you're basically, frankly, it's free. Amazon will give you a free tier that gives you 1 million Lambda invocations every month for free. What this means to JAMstack developers and developers in general is, yes, servers exist. We all know that in the serverless ecosystem. Servers still exist. It's not like the code runs on, hopes and dreams. It's running on servers. You just don't have to worry that it's running on servers or what servers it's running on or how it's even running. You just say, here's my function, please run it in response to events. So event-driven is another big part of this. We're going to talk about what that means. But for JAMstack people, basically what this means is focus on your front end. Focus on building the front end. Focus on your business logic in the back end. Don't worry about the servers. You don't have to SSH into anything. Frankly, you cannot SSH into anything. We're going to see that. And you can just focus on that business logic and your front end. Don't worry about all of the other stuff that you normally have to worry about. So this is super small. Hopefully some of you can see it in the back. It's not just APIs. That's something important to realize about serverless and the serverless framework. We have people using it for all sorts of stuff. Everything from replacing that old cron server. You can schedule AWS Lambda functions to run. You can do webhook listeners from GitHub, for instance, to automate and operationalize some of your stuff. Stream processing off of things like Kinesis. Build chatbots, voice bots. IoT is actually a really huge use case. You have all of these devices, thousands, hundreds of thousands of devices out in the field. Hook them up to IoT Hub in Amazon or other IoT providers. They'll send payloads of data every so often. If you have 100,000 devices, sending in 100,000 or sending in requests once a minute, that's still 100,000 requests a minute that you have to handle. Servers for that could be painful, especially if you want to try to roll them or update them, manage them. So instead, hook them up to Lambda functions. Not a problem. It will handle all of those requests coming in every minute, every second. It will handle the scaling for you. So web, mobile, obviously. Image resizing is a big one that people like to use it for. More generally, data processing. Someone wrote a library on top of AWS Lambda called Pyren that does a lot of scientific computing in AWS Lambda. And you're basically able to build super massive supercomputers that last for seconds. Not many things can do that. So how to do it? I don't know how many of you have ever opened an AWS console. It's insane. I used to work as an Amazon consultant, and people always asked me, how do you know all this stuff that you know about? And my legitimate answer, and I still do this quite a bit, is I spent about 10 hours a week reading documentation to even have a clue of what I was trying to tell people about. I would pick a particular service or two every week and read it front to back. DynamoDB, front to back, read the whole thing. S3, whole thing. Otherwise, there's no way to know this stuff. Basically, it's just insanely complicated, and you cannot know all of this space. If you're trying to build a JAMstack, just focus on your static site generator, learning those ins and outs. Use something like Netlify to do your actual deployment. Don't try to do it yourself. And then use Serverless Framework and AWS Lambda to actually run those APIs in your business logic. So 2015, Austin Collins, our CEO, was building a startup. Serverless Framework headquarters are in San Francisco. So like any good San Franciscan startup person, he was like, I'm going to build a startup, and I'm going to do it super cheap because San Francisco is expensive to live in. So I want to do it super cheap. AWS Lambda is awesome for doing super cheap stuff. At that point, was very hard to actually build and orchestrate Lambda functions. So he built something called the Serverless Framework. We've had it since 2015. I think we're at 27,000 GitHub stars at this point. And it was the most widely adopted way of building and orchestrating serverless APIs on AWS and 7 other providers at this point. We can actually handle multiple providers from OpenWhisk, which is an open functions as a service, FAS, Azure, Google Compute Functions. The framework has grown, obviously, since 2015. We're going to look at a really strong plugin ecosystem that we have, which allows all of our contributors and community to add new functionality. Even if we don't have it in the core, you can add new functionality to it later. But basically, this framework was built to solve a few problems. First of all, you can actually do serverless infrastructure all the way through to serverless applications. So we'll look at a simple use case for an API and maybe a scheduling a function, and we'll also look at how you can use it locally. It solves architectural complexity. I don't know if any of you have ever tried to use AWS CloudFormation. It's basically tens is an understatement, hundreds of lines of YAML or JSON, and it can be complicated to wrap your head around that. That's another one of those documentation things. If you really want to understand CloudFormation, go spend 10 hours reading the documentation and you have a fighting chance maybe. So we try to solve that problem. We solve application lifecycle management. It's a deployment utility as well. We'll see that in the demo. But you can deploy, update, and remove all with the serverless command line. We solve local development. We'll look at that. To us and to the company, one of the key parts of what we do is really developer experience. So making sure that everything is easy and understandable to the developer, abstracting away complexities when we can, and just providing that experience that people enjoy. And then to us, also vendor choice is a big one. Not necessarily write your code once, run it anywhere. Rather, you are able to take the same utility, the serverless framework, and if you would like to write against Google Compute or Azure or AWS, you can still keep using the same utility to do so. So the command line interface is written in Node.js, so you can do an npm install of serverless, do it globally. You can, of course, do this on your local machine. You can do it in your CI/CD systems. It's pretty easy just to install. And then we're going to look at this, but you can create from templates. We have templates out there that are public. You can say AWS Node.js, AWS Python, and it will basically scaffold out your project. And then deployment. What we really try to do is offer a YAML-defined file and interface for a serverless application model, right? Tell us your provider, tell us your functions, where is the handler for your function, basically where is the entry point to your code, and what events do you want to use? Do you want to use HTTP or schedule your function, IoT or Alexa skills? And we'll parse this file and basically figure out what we actually need to do in terms of CloudFormation or whatever your provider is to deploy that application for you so you don't have to worry about it. Lifecycle management, so I talked about this a little bit, but basically you're able to deploy your functions and service. You can invoke your functions in the cloud if you would like to. You can fetch logs for your activity, for your services. You're able to roll back, remove, all of that good stuff, and we solve all of those problems for you. You don't have to go figure out how to do that in the provider that you're using. I just skipped a bunch. Like I said, we have a bunch of different use cases. These are just a few of the templates. This slide is actually pretty old. There's a ton more out there, especially with the release of Amazon's layers for AWS Lambda, which meant you could bring your own runtimes and all of that kind of stuff. So Node.js is one of the biggest ones, of course, Python, Java. And then our plugin ecosystem, we offer, and the community offers, tons of plugins from everything for doing different kinds of auth on your APIs to offering static deployment, for instance, to S3 if you're not using Netlify. There's a plugin to be able to do deployments of static sites straight to S3, and it will handle the lifecycle there. Offline simulation of DynamoDB, if you want to do that. Offline simulation of API Gateway. All of those are offered as plugins. So this is interesting. Usually what really gets people to understand why this is so cool, though, is tempting the demo gods and trying a simple HTTP endpoint. So we're going to do this and see what happens. And we don't have a mic stand, so he's our mic stand, sorry. All right, so I'm going to mirror here quick and pull open. I'm actually using AWS Cloud 9. Can people in the back see the text? Okay, so I'm using AWS Cloud 9. This is like AWS's editor that runs in the cloud. So I'm using a Chromebook here. It's not, you can run Crouton and things, but backing this is an EC2 instance. That's kind of not super necessary to know, but if things go wrong, it's not my fault or my machine. It's EC2. So getting started, we'll do serverless. So of course you can do npm install serverless global. I've already done that. It takes a little bit to do, probably about 10, 15 seconds because node. But we'll go ahead and actually create a new project, right? So serverless create, and we're going to do it from a template, and we're just going to do Node.js. And we're going to call it JAMstack. And I think that's all I need to do. OK, there we go. So behind the scenes, what this has done is actually create a serverless YAML template file that has the things that we need for a minimal deployment. We'll actually go ahead and do that now so you can see what happens. So I typed one command, and now I'm going to do serverless deploy. Behind the scenes, this is actually parsing this YAML file. Everything you see that's gray is commented out. The only stuff that matters is like the red and white here. So we have JAMstack running on AWS with Node.js 8.10 runtime. And then the only other thing that we're doing is we said, OK, we have a function called hello with a handler at handler.hello. If we go look at our handler JavaScript file, basically it's just this. It's an async function. Async is fully supported, so you can do async await stuff. And we have our hello function here. This is basically our business logic. Note, I did not start an EC2 instance. I didn't have to click around and like provision servers. I didn't have to click into the CloudFormation console. I didn't have to do any of that. All I had to do was create from this command line interface, pull this template, do a deployment. Behind the scenes, it's actually going and handling all of the CloudFormation stuff for us, compiling CloudFormation, going out to AWS and running it for us, letting us know the results. It set up an S3 bucket to handle all of our deployments of our code and artifacts. So that's all taken care of. So if I actually go look at AWS here, we use CloudFormation behind the scenes. You'll see we have this JAMstack dev stack now. And man, AWS does not like it if you zoom in at all. Hopefully you can see this. We have a bunch of resources. So this is actually orchestrated right now, 5 different resources. We're going to look at something else in a little bit and see how complex this really gets. But I can drill in and actually go see my Lambda function in the console. And you'll see our code that we were just looking at in our editor is now deployed out there. So this function is out on the cloud. You can't actually run it, of course, from an API or anything like that right now. This code is just kind of living out there. I could, of course, click test and get some test runs or invoke it manually. But that's not the interesting part, right? The interesting part, especially for JAMstack people, is how do I access this from a static site? How do I actually make this useful? So we're going to do this. Jump back. I talked about serverless and the serverless framework being event-driven. So we offer a really easy way that actually handles all of the permissioning and stitching together of various event sources to your Lambda functions. The way you do that is just define events. Say, I want an HTTP event. I want some kind of HTTP request to get to this function. I'm going to say the method is a GET request, and our path is going to be hello. We'll go ahead and save that and do another serverless deployment. It should go a little bit faster this time because it doesn't have to orchestrate all of the resources all over again. We already have an S3 bucket provisioned. What this is now going to do for us, though, is set up an API gateway, set up all of the IAM permissions, the identity and access permissions from AWS between API gateway and our Lambda function to invoke it. And, of course, set up the paths on our API gateway. So all of that I've actually written, I think 4 lines of code here. Everything else so far has been handled. I actually get this GET request at a live URL. If you can type really fast, you might be able to get to this. But if we go look, you'll see I have my browser is actually invoking this function, and the function right now is built basically just to echo back everything about the event. You get a whole bunch of information like headers and all of that in your API gateway. So if I refresh this, you'll see I get a little bit of different content every time, but this is completely live. If I want to, I can go in and say, you know what, let's simplify this to only give back just our message. We'll save, do another deployment here, wait a few seconds, and CloudFormation, once again, we're using CloudFormation, it will handle the state management. You can do this while people are hitting the endpoint, and it will manage spinning up new AWS Lambda containers to start handling the new request in parallel with the old ones. So if you have requests going on and on, that's not a problem. There shouldn't be any downtime. It will handle pretty tremendous load while that's going on. So now if we go back to this URL, you'll see we just get this. We updated the function that fast. Now, what I like to show people here, we'll see if it works, is this is cool, right? This API is out there, it's public. You can start hitting data sources, DynamoDB. You can start serving back images or binary. All of that stuff you can do from this API now, right? And we didn't have to worry about servers or any of that stuff. This stuff, though, is basically production ready in terms of being able to scale. And the way I'm going to show you that, and we'll see if this works, Amazon already banned me once today on my EC2 instance for doing this. I had to get a new one. So we're going to run a load test. This first one is going to be pretty simple. We're just doing 5 concurrent users on 2 threads for 5 seconds. So there we go. We did that. Our latency is 58.43 milliseconds on average. And in the worst case, it was 590 milliseconds. And a request per second was, on average, 65 requests per second. Once again, no servers that we have to worry about. We're just handling that load out of the box. But that's not interesting. Where this gets interesting is when you do something like this. Let's run for, let's say, let's do 10 seconds. Let's do 20 seconds. I don't want to wait that. Let's do 50 concurrent users on 10 threads. We'll see what actually happens here. My EC2 instance might actually get throttled because of too many requests coming from one IP address. OK, there we go. So we had 1,900 requests per second against our API. Average latency went up a little bit. And we had our max was 1.68 seconds. If I were to run this again, that stuff would improve. And it's because of how quickly they're scaling Lambda behind the scenes. If you were to try to do 2,000 requests per second against, like your single EC2 instance, unless you had some really crazy optimization going on, it'd probably fall over. And EC2 cannot scale this fast, even if you have alarms and triggers, right? I've built API gateway systems that are API gateway to Lambda systems that do in excess of 100,000 requests per second, no problem. And I've never had to wake up in the middle of the night to actually fix one of these things. Yeah, yay! I used to do Docker stuff. I don't do that anymore. I do this. And that's because behind the scenes, Amazon is maintaining all of the clusters and stuff for scaling and all of that. Once again, I'm only paying for the request that I actually execute. So if I were to never execute this API again, I wouldn't pay another penny in costs for this to be running. Any questions on what you just saw? I just did that awesome of a job. OK.
Where's this stored in version control?
So that part, you could do Git or something like that. The actual version control in terms of your code and your serverless.yaml file and anything that you're using to actually run your project, once you deploy it to AWS, they actually basically grab the artifact out of S3 and then will manage spinning it up when they need to in Lambda. You can store this in your actual project, though, in GitHub or GitLab or any other Git or SVC, like whatever version control system you want to use. The key is that, this code and this stuff, once I do the deployment, I've handed it off to whatever the provider is, and it's their responsibility to make sure that it's doing what it needs to do. This stuff, I could turn my machine off and that API endpoint would keep working.
Some of the outliers that you run into when you're building out some of these APIs, hardware needs, longer running processes, long running, like memory intensive or compute intensive stuff. How do you judge what's going to fit well here? How to pick a provider in those situations?
Hold on. Yeah, so that's a really great question. Honestly, that's one of the situations where I think it comes down to knowing what your providers have in terms of just capabilities, right? So like AWS Lambda, I think right now can run up to 15 minutes is the maximum time, and I think is it what, 6 gigabytes? Somebody know? I don't know what the maximum amount of memory you can provision is right now. You can do some pretty intense stuff with that. That said, if you need to break out to something like Fargate or have durable functions like Azure, where they can like run over time and kind of get like asynchronous callbacks within the functions, it really comes down to knowing the provider. Basically, my rule of thumb is I like to keep Lambda functions running less than 30 seconds if I can. If not, there's other stuff out there, whether it's like Fargate or Kubernetes and like schedule something on Kubernetes. Maybe that's a better fit for some of those, especially really intense like machine learning and stuff like that, where you need GPUs. Like, you're not going to do it on Lambda right now. Some of the serverless stuff maybe, but try to keep it bound to stuff where it's usually less than 30 seconds in response to an event. Some of the data processing on like S3 files, where a file comes into S3, processes in Lambda, you can do that. It's really situational, though. Did I answer it? Yeah. It's a tricky question. I know what you're asking. Yeah. All right, we're gonna jump back to our demo or our slides here. So I talked about architectural complexity a little bit. The best way to kind of demonstrate what I mean when I say serverless framework solves architectural complexity. So everything you just saw, this is what happened. And behind the scenes, it actually created 9 AWS resources. So I wrote 4 lines of code, created 9 different AWS resources, which is these. In our serverless.yaml, it's 11 lines. If you go look at the JSON generated, even if I take out all of a lot of like the unnecessary line breaks that it does when it prettifies the JSON, it's still 200 plus lines of JSON in CloudFormation, which is really painful to write and actually get right. So we solve a lot of that complexity and all of those unnecessary things that are implied when you say, of course, API Gateway needs permission to actually execute a Lambda function if I want to hand off an event to Lambda. So we solve all of that behind the scenes. Event-driven, so I showed you the HTTP event. If you wanted, you could, for instance, say when a file or some kind of file gets uploaded by a user, and you can do this in a Jamstack, upload directly to S3, a Lambda function can trigger after that upload and go do post-processing. So resizing avatar images or resizing images in general, applying filters to images. You could do that with Lambda as soon as a file lands in S3, execute on a Lambda function. You can schedule these Lambda functions either with cron syntax or say run at a rate of every 1 minute or 5 minutes or once a day, and it will handle running those processes for you. So you don't have to keep that like old EC2 box or old box around that's nothing but your cron box that runs those cleanup scripts for you. You could do that with a Lambda function, and then you're not paying for that server for the other 23 hours and 59 minutes in the day that you're not using it. So that's actually a pretty big use case as well. That said, there's tons of different use cases for this, IoT, all of that I mentioned. Local development. How are we doing on time? Got about 5 more minutes. We can do it. Can I get you to hold the thing again? All right. So we're going to switch back here. I'm actually going to show you local development because this is actually important to folks that are building like local websites and you're developing locally. You want to see usually how do I do this like offline, right? You saw me deploy to the cloud and hit the API in the cloud. That's not always the greatest, especially if you want to develop maybe business logic in parallel with your static site. So serverless has this plugin ecosystem that I've been talking about. And you can actually search our plugin ecosystem. So let's say search for offline and see what plugins we have that might pertain to offline. So we've got a bunch here. We can simulate SNS offline, SSM, offline scheduler. It will pretend to run Lambda function scheduled. The main one we're going to look at, though, is this serverless offline plugin that allows you to emulate API gateway and Lambda on your local machine. So serverless plugin install, and our name is going to be serverless offline. This will go ahead and go out, reach out, grab the packages, pull them in. It'll create a package JSON if you need it. I'm just going to npm install just in case. So I've installed that plugin, and now if I do serverless and run our new command, which all of our plugins can hook into our command line system and basically offer new options, new command line flags, all of that stuff, as if it's a native part of the framework. So now if I run serverless offline, you'll see it boots up a localhost server on 3000. Of course, you can adjust the ports. It tells us, hey, you have a route at get hello. And then if we go create a new terminal here, and I curl localhost 3000/hello, I get a simulation as if it were running in the cloud. It runs Lambda, pretends it's through API gateway. So this gets really useful because it has hot reloading. And as you're working on your business logic, whatever it's connecting to and doing, and you're working on your JAMstack, your front end, you would be able to adjust your business logic, have it simulated all locally, and really quickly develop. And that speeds up the development cycle tremendously, as opposed to trying to deploy out to the cloud after everything. Not everything can be perfectly simulated locally, but this at least will get you most of the way there. You can usually mock other data sources if you need to. That's all I had for the demos. Thank you. So we're going to jump back. And they worked. That's good. So we're going to jump back here, finish off the slides quick. Yeah, go for it.
So can we do generation from Swagger definitions to local stubs in serverless?
Yes-ish. So you are able to use some of the Swagger stuff. There's, I think, a plugin for it. We don't natively support the Swagger stuff. That said, I think there's a plugin for it, and yes, you'd probably be able to do it, I think. Yeah.
For the Swagger, actually, you could embed it into the field in CloudFormation,
yeah.
And then you could also use the document, that plugin, but
Yep.
it's basically the same thing.
Yeah.
It just does the same thing behind the scenes.
Yep, thank you. Did you have a question? No? Okay. We already did this one. So developer experience, like I said, the entire framework is CLI itself, and the way it's actually built is on top of our plugin architecture. So basically the core of the framework is just plugins that we have blessed and said, these are core plugins that ship with the npm install, which means that we are operating within the framework on fair footing as everybody else. So anyone else can actually go and write a plugin that once it's installed will override functionality of core plugins if you need to do that kind of thing. So it's all hook and lifecycle based. Even plugins, so like the offline plugin, for instance, can offer its own hooks or own hooks and lifecycle events that other plugins could tap into as well. So the whole plugin ecosystem is pretty well thought out, pretty elegant, and super extensible. You can always basically write a plugin to do anything you want. I know I wrote like a plugin that would make it so all you had to do was say, I want like a Kinesis stream, and behind the scenes it would go set up like 15 resources to make sure your Kinesis stream was always encrypted, always archived. You could replay your Kinesis stream, all of that stuff with one plugin, and people just had to put like one line of config inside of their templates. And what that gives us is a really strong ecosystem. There's hundreds of plugins out there that you can go use to improve your life and make it easier to work with. For instance, a lot of enterprises that we work with in this space will have really complicated requirements, whether it's around security or auditing or things like that. And instead of trying to force those down the developers' throats with other kinds of tooling or things like that, they'll write a plugin that just runs those enforcements for the developer. And the developer just says, put this plugin in my serverless YAML file, run it in my project, and it will just take care of all of that stuff for the developers. Once again, developer experience. Yeah, so packaging is another big one. Packaging for Lambda is interesting. So if you're running on like a Windows box, the framework will run. But if you try to take like native dependencies from Windows and run it in AWS Lambda, it will fail because AWS Lambda is Amazon Linux-based runtimes. And so if you have like Postgres or like MySQL requirements or other native requirements, if you try to ship it with the Windows dependencies, it's just going to bomb out and have no idea how to run those. There's stuff out there, there's plugins out there that will actually, for instance, use Docker to pull the correct dependencies, package everything up, and when it ships it to Lambda, it will have all of the correct dependencies, and it just makes that process easier as well. So we also support all of these other providers. I know I talked a lot about AWS and Amazon Web Services, of course. We support all of these others, and I think a couple more now as well. Amazon, of course, is the bulk of our users actually right now, but we're definitely seeing people migrate towards other providers. That said, we're dedicated to supporting any provider out there that wants to be part of the framework. So if you are operating some FAS solution or for some company, come talk to me. But yeah, that's all I had about the serverless framework. Yes.
Did you have a web task before?
I think
solution?
We did,
Is
but
it
did
gone?
they shut that down?
No, I don't think so.
Did they? Okay.
But I don't think it's on your site anymore.
I don't know if I don't know if the plugin might not have been supported after a while.
Oh, yeah.
I don't actually know. Questions?
So when you were talking about packages, one question came into my mind. One time I was trying to install some packages that are over the storage restriction. Were you able to resolve that issue?
So that's actually an Amazon for Lambda and an Amazon enforced thing, right? Your unpackaged Lambda function can only be so big, like once it's unzipped, and your packaged function in terms of the zip size can only be so big. I know they increased the size. I don't know how big it is anymore. I haven't run into that problem. But there are tricks that you can do. I know the Python packaging plugin would actually go and remove like all of the unnecessary documentation and stuff like that from vendored like pip files and those Python packages. That said, no, we don't handle that natively, but some of the plugins do.
Thank you.
The company we work at has a couple services that are currently being deployed using serverless, and then we have some legacy services that either have been deployed on their own, like CloudFormation stack, or in a case of bad judgment, maybe we're just deployed on various services. But is there any existing documentation or guides about switching an existing service over to serverless, or like are there any plugins that help with, for example, maintaining data currently being stored in some service, anything like that?
Yeah, so that's tricky. Specifically with Amazon, since we use CloudFormation, usually if there's like pre-existing resources, you can't pull them into CloudFormation. And since we're dependent on CloudFormation for like our state management in terms of deployment, no.
Okay. All right.
Yeah, sorry.
No, good to know.
Talk to me about version 2 later. Yeah. What? Kind of, yeah.
When provisioning a DynamoDB in serverless YAML file,
Yes.
is there a way to successfully redeploy that
Yes.
without the failure? Because when you redeploy the YAML file, it fails because the DynamoDB already exists and kind of.
Talk to me later. I know exactly what you're talking about.
Okay.
Yes.
There is a way. Okay.
Yep.
Cool.
What do you recommend for your development lifecycle around the development lifecycle around serverless functions, being a collaborative in a collaborative environment or through GitOps, or I mean, how do people collaborate on these?
So like CI/CD, like team-based stuff, or just like how do I write my service and somebody else writes their like on the same service?
Yeah, I mean, so standard development on a code base, you're gonna have multiple people working on it.
Yeah.
First control,
Yeah.
test, dev,
Yeah.
preview.
So serverless has the capability of doing something called stages. You can do like it's a command line option -- stage something, right? You could also we didn't talk about it. There's like this whole serverless variable resolution stuff that you can do within the file. One thing that I know is actually pretty common is to use that variable system to use like your branch name as your stage name. So as a developer, you cut a new branch, start developing, do your deployments to the cloud if you would like to, or through your CI/CD system. And with that branch name as your stage name, you shouldn't collide with anybody else. And then merge into like your trunk of your code repository and have that be like your shared dev. And hopefully you shouldn't be trampling each other in there. But make sure you just use that stage thing. You have to make sure all of your resources are also properly named. And either using, naming with the stage as part of the name for a convention, or just let CloudFormation, if you're using Amazon, name those resources for you, which I always prefer that practice. But yeah, the stage thing is pretty much the main key for not trampling each other when you're developing.
Is there like a reverse proxy or a tunnel built into serverless to let you share stuff in
No, so no. With this the serverless offline stuff, you could use some other like reverse tunneling system to share those. That said, if you're deploying to the cloud with those stage names, basically you would get unique like API gateway URLs or something like that. There's some other plugins that offer different ways of thinking about it, with like stage names being on the same API gateway with like /stage name /stuff. But yeah, the stage is going to be your core way of handling dev across teams. Any more questions? I know we have our next talk up.
Thank you, Jared.
All right, thank you.
Thank you, Jared. That was really awesome. We make heavy use of serverless at Netlify. We actually recently moved our screenshot service over to it, and we're doing we do tens of thousands of deploys, so we're triggering hundreds of thousands on serverless, and we don't have to worry about scaling. So next up, we have Sergey, who's going to talk about generational deployments as opposed to static site generation.
Yeah. So, hello everybody. I see many of you are younger than me, so you are a dynamic generation, right? No, it doesn't work like that. No, sorry. I see a few familiar faces, but a couple words about myself. I love speed of user experience, also called in the industry web performance, although it's a loaded word. But I organize a meetup group about it. This 10 years this year, actually, pretty old group. We talk about, we have speaker sessions every month, and we also have hands-on sessions as well to help people optimize their websites. And speaker session Next speaker session is on Tuesday, actually, about scaling the culture of web performance. If anyone is interested, please check it out, NY Web Performance Meetup. And now I actually work at Meetup as well. So I'm joking that I don't only run Web Performance Meetup, but I also do web performance at Meetup. So anyway, that's what I do, and I love this stuff. So why do we generate, right? Like this group is a lot about generation of content, right? The word static generation was mentioned multiple times. Basically, who can relate to not running your own runtime? Who loves that, right? No PHP, no Ruby, no? Java maybe? Anyone ran ASP.NET before? No? Yeah, so welcome. Welcome to the world of none of that, right? Server administration, obviously, tools like serverless, awesome invention as well. But managing that for our static, let's call it content, or content that is not interacting with the user is just awesome. Who loves databases, huh? Anyone? Anyone? 3 people love databases or love that we don't need to care about them anymore? Which one is that, right? So all of those are awesome conveniences for us as creators of the applications, and this is just amazing. I love that, right? But there is one other thing, right? Other than scalability, solutions like serverless allows us great scalability. There is this thing called speed, right? And users don't want slow experiences. And this is what generation helps with, because this is the metric called time to first byte, right? For HTML specifically. It tells you how fast does first HTML arrive for each web page view, right, to the user. And this is like realistic data from some website where this time to first byte is the distribution. It's never one number, right? Speed is never one number. So this is a distribution of, for different users, how fast that happens, right? And you can notice that long tail above 4 seconds, right? Like everybody, that's what that last bar is. It's not like a border or anything. It's actually a data point, right? So it's always a distribution like that. And it's not only high on average in this particular case, right? But it's also very variable, right? So almost 4 seconds, right? Jared showed the statistic with distribution, right? That's basically what this represents, right? The 95th, in this case, percentile is at almost 4 seconds. So what it means is that 5% of your users have experiences slower than 4 seconds, I'm sorry. And this is terrible, right? Because HTML is a bottleneck. Nothing can happen on a page. Nothing can be shown, loaded, interacted with, or anything. And even nothing can even start downloading your JavaScript or anything until that happens. And in traditional systems, that distribution that I showed you is not uncommon, right? How many of you used WordPress before, right? Shared hosting, you know, your WordPress is like, yeah, that graph is actually very optimistic for what WordPress does. You know, comparing to what WordPress is I see. And at our hands-on sessions when we run and analyze websites, we actually ran a meetup, joined with WordPress meetup and talked about it. You know, it's not uncommon to do, right? While for this particular website, you see that this website ran static resources as well off of Amazon S3, right? Served like all of the JavaScript, HTML, CSS files, and that is the distribution for those files, right? 480 milliseconds on average and 629 milliseconds at 95th percentile, right? It's not only faster, but it's significantly less variable, right? So users have a consistently fast experience. And when we talk about generation, that basically moves your HTML from being dynamically generated when a user requests it to being the same as your CSS, your JavaScript, right? Well, you guys are at this meetup. It means you know this awesomeness, right? But this is significant, right? This is great because this first request, again, is a bottleneck. Why does it all matter? For those of you who don't attend my meetup, please take a look because almost every meetup I show this slide. These are use cases, business use cases about speed. If you're interested, wpostats.com, it's like much more on the website, many more examples, where it correlates speed to actual business value, right? So if you need to talk to your business managers and to your folks, which is always a nightmare, like to explain technical stuff, right? You tell them serverless and they're like, oh, come on, you geeks, right? Here is an example of how to sell it, right? And the numbers are mind-blowing. That's frankly, when I saw these numbers back in 2006, actually, even maybe a little earlier than that, that's why I started the group, right? Because numbers are just crazy. Imagine tripling the revenue of the company by doing something technological, right? How many business people will pass on that, right? Nobody will, right? They would not believe you. That's another story, like how to convince you. But hopefully these numbers help, right? Until you can show this benefit on your site, these numbers can help. So it's very important, right? SEO, like they're like just, I mean, read the site. I don't need to explain it to you. By the way, cultural implications we will talk about on Tuesday, right? So I assume, how many of you ran or worked with other websites that are not statically generated, that are big production kind of enterprise systems, right? Oftentimes, well, cache is not used there either, right? But the moment the conversation of speeding things up significantly comes around, cache is edge cache, CDNs, right? Is the first thing that comes to mind for people, right? And today I wanted to talk about start at least with kind of comparison between cache and generation. Why do we generate? Why don't we cache? That in the end, the idea is the same. You don't do real-time processing, right? So this is how cache looks like. Essentially, you have a lot of users in the world. They all access your edge servers provided by some vendor, CDN vendor, which makes requests to so-called origin server, right? And that origin server usually reads data out of a database, hence WordPress or some other applications like that. And all of that happens when user makes a request, right? So when updates happen, they're written into database and the next request from the user goes and grabs it. But CDN can be configured to say, hey, this particular response, please remember it for a particular period of time called time to live, right? And that's those little TTL labels under the nodes show that, right? So next time a user comes to that particular node, they will be given pre-calculated response, right? That being said, there are multiple nodes in the world. Well, multiple as in like hundreds of thousands usually by individual vendors. So it's not like you get only one request for a resource to your server, right? You get quite a few resources, quite a few requests. So comparing that to generation process, we move up origin all the way to some kind of storage. Many of you use Amazon S3, I can imagine, or through services like Netlify, it's abstracted away from you, right? The point is that when the requests coming through this CDN, they go and hit a statically saved file already, right? So it's not only saved on the CDN, it's saved as a resource already. And all the updates and all of the generation, all of the processing to create the output is actually done on the moment of the writing of the content, of changing the content, right? Usually it triggers the rebuild, your process somehow gets the data or maybe keeps the data as part of the Git repository or something like that, and builds the whole thing and redeploys, hopefully only changes, to this static storage. right? As you can see, the read of reading during the request is much shorter, right? Like meaning that, first of all, it's also geographically shorter usually, but more importantly, you don't go all the way into your infrastructure. In addition to that, because the generator knows which resources it generated and deployed, it can also use cache invalidation technique, where it tells the CDN to stop caching, forget the old resource, invalidate it, right? Because of that, the time to live can actually be infinite, right? So if you compare the two techniques, cache renders on the read scenario, basically like non-cached resources, right? It does remember the result, but when it's read, that's when calculation happens. When in generation, it happens on the write. It does use the TTL technique, and the staleness of the resource depends on the length of the TTL, right? Because you don't know when user hit it, right? Like you cached it now, user hit it in 15 minutes, it invalidates later, like in 20 minutes, it means 5 minutes stale, but the user could have hit it right when you deployed it, so it will be 20 minutes stale, right? So average staleness is half of your TTL essentially, right? Among all the users. That, unfortunately, makes people be very conservative about this caching, right? Because you cannot invalidate, because you don't invalidate, right? That's why you like, oh, let's put it like 10 minutes and we will be safe, right? So 10 minutes staleness is not a huge deal, at least like in publishing world, I heard these conversations a lot, right? So your effectiveness of cache is not very great either. While with generation, it's 100% hit rate, right? Like the moment you deployed, that resource is available until it's overridden, right? And staleness depends on how long you deploy, right? Your data changed, it takes some time to deploy. That's how long your data is invalid, like, or stale, I should say. It's not invalid, it's just old, right? Well, some can argue that it means invalid, but it's old, which is not the same because, well, things take time anyway. You know. Another aspect of the caching system is that it always needs an origin, right? You need to run those servers. There is no way to not run them, right? If your authoring system went down, right, and there is no data, oops, that's a problem, right? I mean, there are obviously solutions for that. So when we say cache only depends on TTL, it's also not completely true, right? Because cache is not caching forever, right? It's not caching universally. We discussed there are many nodes out there in the world, right? So if one cache has it, it doesn't mean another cache has it. Moreover, if you have many users, CDN node has many clients, well, it could have evicted your resource from the cache, right, at that moment in time, right? So it's a shared resource. I'll actually talk about it a little more later. By the way, if anyone has any questions, please feel free to ask them. There is no need to wait.
I have a question that might sit outside this a little bit, but I have a question that might sit outside this a little bit, but do you ever hit issues with browser caching or anything like that in terms of either of these scenarios? In terms of keeping...
It is a little bit outside. It is also cache, but it is a different type of cache. Some of it can be related, but I would like not to talk about it right now. Okay, let's talk offline separately, right? Okay. Okay, so some of you will be like, okay, so why did you invalidate here and didn't invalidate there, right? Like, why are you talking about this inefficiency if you could use invalidation in here as well, right? Well, the difference between generation workflow and this workflow is that in generation workflow, you know exactly what to invalidate, right that moment, right? But in caching workflow, you can invalidate, but all of that logic needs to be stacked on top of your existing system, and you need to put all of that logic similar to how you know to logic for generation, you need to create that kind of logic to go and do invalidation, right? But it is possible. That's kind of what people do in advanced scenarios. Like they put infinite TTL. So if you notice the difference between the two, here the TTL is like conservatively low, and here it's an infinite TTL, and then you invalidate things, right? And when you invalidate things, it goes, grabs the new version, and serves a new version later, right? So let's compare invalidation process with generation. Which one is better, right? I mean, we love generation, right? Like, can we do invalidation instead? Will it be any good if we need to do that for systems that we cannot do static generation for? So first of all, it requires an API call with most of the CDNs. So you need to actually integrate that, right? While with generation, invalidation happens on deployment. That's kind of the point, right? There is a way to configure a CDN to do stale while revalidate, meaning that when you invalidate something, it will not stop serving a resource and go to your origin for request, right? It will serve the old version, similar to generation, right? Until you deploy it, it will serve the old resource. So that's actually on par, right? If you think about it, you will serve old version. Well, granted that that particular cache engine has the old version at that moment, right? So there's still origin needed, but you could do quite progressively with stale while revalidate. So, okay, again, the same kind of level, not again, sorry, API call was kind of disadvantage, but minor disadvantage if you think about it. Then comes a more complicated question. What is that you're invalidating, right? Because nuking the whole cache is kind of not a great solution, because what does CDN do when you do that? It comes back to your origin and kills it, basically. All of the requests start going to your origin when you were not really hoping for that, right? Like you had your smallest server by then, and you're like, okay, now none of your data is valid, like dead, right? How many of you experienced that in your life? Here we go. Yes, that's fun experience for sure, right? But I mean, you could do a little smarter, and sometimes people break up the whole cache into like sections and like CP codes if you're a Akamai user and stuff like that, you know. But there are more advanced techniques like surrogate keys. Fastly, for example, supports it. It kind of came out of Varnish world, where you can tag each response with whatever keyword, right? And this way configure things to only invalidate a subset. I mean, you can obviously invalidate just one URL if that's a thing, right? But you would not. I mean, you would not go and invalidate 1,000 invalidation requests, right? You will just tag them and invalidate them all together, right? So it's kind of similar to incremental building in static generation, right? If you only updated these resources, well, actually, incremental deployment. If you only updated these resources, go and invalidate only those resources, right? Kind of similar. Again, kind of on par, right? So if you look at it, these techniques are more or less the same with minor differences, except for the kind of the price that you pay for edge cases and things like that. So first of all, we discussed shared CDN nodes. Node in Moscow, so they're called POPs. Points of presence, by the way. You know, points of presence in Moscow might not have a resource that you're trying to fetch, right? And when POP in New York cached it, Moscow node doesn't know about it, right? Akamai, I think, has 100,000, or at least they declare 100,000 POPs, right? So all of your users are not accessing the same cache at all, right? But also, you have long tail content, right? Things that are rarely accessed, right? Among your million pages, homepage is accessed quite a lot, but like some rarely accessed resource, it's unlikely to survive in the caches for a long time, right? Because those caches are usually least LRU caches. Least recently used, that's right, I'm blinking out, sorry. So it means that it will evict, all of those nodes will evict your rarely used resource, and your hit rate will be very low, right? It will always go to origin to generate, right? It's not, as we discussed, there are a lot of things that you can do to minimize that, but still you will have that impact, right? You still need origin. You need some of your users, though, remember we talked about 5% in the end, right? Like distribution will still be flat, right? While with generation, well, whatever you generated will be there, right? You have a long tail, well, you pay for the storage, and once you pay for the storage, however billion files you have, there will be billion resources to serve, right? And there is another obvious cost. It takes time to generate, right? You take CPU to generate. So the narrower you are in what you regenerate, the better, but it's a hard problem to solve, right? And probably you all know it because you use static generators and they freaking regenerate the whole thing. Some of you use Hugo, though, I hear, right? And that's much better, right? Yeah. I'm not a huge user of serverless, so and I don't have sides. I don't take sides in this fight, right? But that's a kind of a problem, right? Especially if you have a lot of data. And that's kind of what I want to talk about in the second part of the talk, kind of talking about different versions of static generators and generation workflows, I should say. Starting with the most common one, the static generation out of Git, where all of your data is versioned in Git, events are handled by Git, webhooks, whatever that process is, right? Even if you use this external CMS will publish content into Git, right? And that is kind of a centralized data store, right? Pretty good. Doesn't solve for content contributed by users necessarily unless you have that service also doing the same thing. Kind of breaks on like billion terabytes of data. I'm kidding, this is a big number anyway. But on high amounts of data, on high amounts of updates, right? Might not work for your huge enterprise, let's say e-commerce website, right? With a lot of sales and things like that. But it's robust, it's kind of has everything controlled in one place, and we love it for that reason, right? It's amazing for smaller projects, does magic, right? There are also static generators that do API calls to external systems. If you ever used Contentful, I think it was their first thing. I don't know if they publish to Git these days, but they definitely like specialize on content as API, right? Or any other external resources or whatever, right? And during your build, you can go and like you have your code running in your repo, but it goes and fetches list of data, either all of your data or some of your data, maybe depending on what you do, right? Also great, right? It's fully generated. Everything again is statically served off of your S3, but your build needs to assemble all of the data, makes it, makes that happen. I assume there are some hooks in those kind of systems that go and trigger the build on change. I don't know if they do incremental builds or not. I assume not. I'm sorry? It's coming. Oh, we have a contentful person in the room. Perfect. Yeah. So my point is like usually these systems manage your data but not your build necessarily, and it kind of depends on your build system to be able to do incremental build only of data that has changed, right? That's kind of today that's kind of an issue from what I hear, right? And as websites grow, statically generated websites grow, people starting to feel the limit of this approach because of this problem. There is also another approach, right? As we just talked about serverless, right? If your main dynamic system or user interaction system uses HTTP REST API, let's say what's the API gateway from Amazon, right? And that's how you manage data. Well, you don't need to worry about your main skeleton of the website or statics page generated. You just deploy only static thing, and the production thing, the dynamic data comes from API on the fly. There is a cost to that, obviously. The problem of getting that data comes back to, well, that can be slow. That's definitely not as narrowly distributed as your statically generated things. It can be fast, right? Like, but our slowest request was like 1.9 seconds, right? Still high, right? And again, when we use some data store, like there's no magic, right? Like things take time to generate, right? Or whatever it's, the word generate here is to create, right? If you make a request, it takes time to create output out of it, right? So this last approach works maybe for like secondary content, like maybe how many of you use comments plugins, like Facebook comments or things like that, or some other service plugins, like you know, like discuss, yeah, they're like okay, they were called widgets back in the day. You will include it. It's somebody else handles it for me. I'm okay. My main content is managed through static, right? But none of these approaches really work for very data-driven systems like e-commerce, right, where prices change a lot, inventory changes a lot, just user contributions change frequently, right? And sheer amount of volume kind of makes some of this system break, right? Length of build, monolithic builds, it's kind of problematic. So essentially what I want to talk about is dynamic generation, right? I think my goal is to convince you that you can go and expand these techniques that we all love to all types of data, right? With some additional changes to your architecture, right? So whenever you come to your boss in your big enterprise account, some of you raised your hand, right? And they say, oh, static generation is only for blogs, or whatever their excuse is to not use static generation. You can say, well, we can make the same technique to make user experience very fast for similar technology, but we need to re-architect some of our systems to do dynamic generation. So the word static doesn't happen there, and they're not like, oh, our data is not static, we are like dynamic, how can we use this shitty technology, right? Like they don't have that argument anymore. So I propose the dynamic, and by the way, I just realized, but that the group is called the new dynamic, which is exactly what we are playing at here. Right? So let's call them dynamic generators. Again, this is not a technology that exists today that like serverless, you can just type in dynamically generate my data. It's a set of approaches to do that, right? So if you go back to our generate with invalidation workflow, right? And expand a little bit, because we have a lot of data, right? A lot of data sources coming at different times and from different sources and all of that. First thing we need is to solve a problem of incremental build, right? And not incremental deployment, which is somewhat easier because once you build them, you can compare two sets of files and only deploy those that has changed, but or use timestamp to deploy. But incremental build, how to not regenerate things that didn't change. If you have a rate of change for your data at 1,000 a second, 1,000 rebuilds of the whole site is kind of problematic, right? Even if you narrow it down a little, segmenting, it's kind of hard. So you need to build some kind of system, which I call dependency manager, like it's right between the build and the data store, right over there, that little box, right? That will figure out what is that we need to rebuild, right? Things that probably need to be added to our current static generators. We are all waiting for that to actually happen and to work well, right? What does it do? First of all, it goes and figures out what is that we need to regenerate, right? Which files do we need to put on a disk drive and run that rendering process for, right? Then configure proper rendering variables. So good example, I listed a few examples, but there are probably other dimensions to your data, right? So for example, authentication role, right? For public user version versus, your member, person who signed up for your service versus a public version, right? Or administrator versus regular user, things like that. Another one is segmentation. People, let's say, based on a marketing campaign, right? They came from this link. We want to show them this type of the service versus that type of service. Very big in like new business where it's like, well, we want to be data-driven, right? Generation workflow is not against data-driven systems, right? We can still generate data-driven experiences. We just need to vary our output based on that. And another aspect with globalization, multiple languages, which users can come from very different locales, prefer different languages. By the way, geo distribution is another one, right? But you can generate. You support 5 languages. Well, you need to generate 5 versions of the output, right? And then this thing triggers the build with those parameters, that incremental build. So your build happens only for this subset of files, or subset of files, and then cache keys, corresponding cache keys are triggered on a CDN, right? And well, your CDN will know how to convert for the same URL under one language or under one user account to convert it into a particular file, right? That is the kind of outside of this. And then you need to figure out how the hell do you manage all of these changes, right? How do you listen to all the changes in all of your data sources, right? That come, let's say, give a e-commerce example again. Your pricing changes on this particular way, right? But your inventory changes in this particular way. Maybe it's a ETL, some kind of data pool for every day or every hour. But for pricing, maybe it's kind of complicated. Well, we're not talking about personalized pricing. Yeah, controversial topic, but maybe your images sync from another content management system, right? Data system and stuff like that, right? How do we do that? The only good way to really unify that, because we now need to know about all of the data changes. We cannot just say, oh, we'll just do this little one, right? Unless we go with the real-time API approach for things that we cannot dynamically generate. We need to handle all of the data sources, right? For that, the best approach is to create some kind of unified pipeline, and some of you, if you worked with event streaming subsystems, right, you probably would kind of find it familiar, right? Kinesis, right, that's the system at Amazon, but there are many enterprises look into this already, right? So when your data source changes, well, your business logic creates a new event, go save it to the database, and also send it to our dependency management system, right? So it can get regenerated and deployed. This is like a classic example of streaming setup, right? Pretty good way of doing that, right? Real world is a little more complicated because I wish we just built streamed system today, right? Usually they are introduced incrementally, one by one. So in reality, you probably will write some data into your databases the way that you do, like without any streaming. But also you can go and mimic that or mirror that update into your stream system. Most of the people probably do that in a similar fashion. In any way, in reality, our dependency management tool doesn't really need to know all the data that has changed. It just needs to know this particular entry in our system has changed, right? That's the minimum you need to know. And then it can go and actually use your regular web server like you do today, like the one that you didn't convert to generator yet, as a rendering engine, which will make that database request once it knows what is that we need to update, right? So this is probably the most realistic scenario for you to start implementing this, adding this to your system as you go, right? Primarily because your data people probably don't move as fast as we front-end folks do, right? So in reality, I don't really want to architect this right side for you, right? You need to figure out how to instrument your data systems to know when data is created, when it's deleted, when it's updated. What are those entities that you have? And that is a thing that you need to do, right? There is no way around it, because without knowing what needs to be, what your data is, you would not know what needs to be updated, right? Another interesting solution that I think might be a good abstraction layer is GraphQL, right? If you're not familiar with GraphQL, it's a new way of querying things, right? Very efficient, amazing. There was a session here before, right, on GraphQL. So GraphQL, in addition to managing all of those queries to your backends of different kind. It also has this concept of subscriptions, right? And subscriptions are basically like, okay, when data updated, go and notify the client that data has updated. So we could use, instead of some of that complexity with event system, maybe we can use a GraphQL front and with subscriptions. We don't do queries, we do subscriptions. For everything we want, we do subscriptions. The moment something changes, go and regenerate it, right? Can be an approach. I didn't work with this approach before, and I kind of, I don't know GraphQL personally, so don't have experience. But for this previous system, we actually did a prototype like that, right? And it worked very well. In fact, we used serverless. We used serverless to trigger a request to the web server to every time that the stream from Kinesis triggered another serverless. And I mean, it was a couple queues and a couple simple serverless functions to orchestrate this within Amazon environment, right? We didn't roll it out because it requires kind of to cover quite a lot of probably majority of your data sources before you can roll it out. So that's kind of a downside. But it is very achievable, very scalable. And by the way, effect was magnificent, right? You could see it with your naked eye. Forget about the tool measurement, right? You could see the effect with the naked eye, right? So figure out whatever you like your GraphQL more and stuff like that. This conversation is kind of that you need to have with your data teams, right? It's not a simple thing, but you can figure it out. I'm not worried. So, what is our to-do list to make that happen? First of all, figure out what are the real staleness and freshness requirements for your data. But because the first pushback I get is like, our data is dynamic, we cannot statically save it. And first thing I tell them, it's bullshit, right? Because your data doesn't update real time. Well, unless you maybe Wall Street trading system, by the way, also bullshit. They have like 15-second cycles and all of that, right? It's never real time. There's always freshness requirement. And when it's a inventory for your store or RSVPs to an event, right? We know when it updates, right? Like it's very clear. It's just that it was never written down, so we rely on every time requesting it, right? So it's a huge bad excuse by data teams. Be ready. Make sure you know how your data updates. Kind of understand how it's done now in your system, right? Because one thing is a business requirement, as a business, like our users have to see data that is no longer than 1 day old, right? Another thing is how do you actually import it, right? Because business folks can think what they think, but ETL people will tell you how frequently it's imported, right? So be ready with that, and that will help you address this problem, because in the end, whatever you implement cache within validation or generation, you will need to know that. There is no other way, because otherwise you will be just very conservative on your TTL, and it will be like, okay, maybe if we cache it for an hour, it will be okay. And I've seen this approach fail a lot of systems, right? It's a good quick approach, right? When you're like, okay, let me guess how stale it is. How many complaints will I get from my business folks when it's stale, right? And things like that. But you do need to know this life cycle of your data before you approach any of this. I'm serious about it. It's like this is probably the hardest fight you will have in your organization, right? And then the product conversation. Map all of your inputs to your outputs. Which data used where, right? Remember those surrogate keys? It's not a simple exercise to know, like when I update this field, which pages get to be updated, right? It's like not a straightforward thing in your complicated databases, right? When in static generation, it's kind of straightforward. It's based on the file you edited, but in databases, it's kind of a hard problem to achieve. Where in the code is used, like how it affects. It's like not a straightforward thing, but it could be done, right? Again, surrogate keys. Fastly uses that on the edge, but the same approach could be used to generate that mapping on the server, right? I have some ideas. If you want to talk, let me know. Then figure out your segments, right? What is personalized, what is not. If something is extremely personalized, maybe you move it to the front-end rendering and front-end requests, right? But if something is segmented, make sure you understand how many segments you have. Like I had this conversation before. Oh, we use geo, right? Geo targeting. It means we cannot really know what the output would be. I'm like, really? You have 3 offers based on that geo? You have 3 outputs, right? Stop bullshitting me about like infinite amount of zip codes in the world, right? Or whatever coordinates on the globe. Like not really. It's about what content you need to output. Same goes about languages and roles and things like that. It can be a large fanning of data, right? You might be generating 20 outputs of one input entry and maybe 100 outputs out of input entry. But it is finite. If it's infinite, okay, then you go and do real time. Particular example here is actually search, right? Search engines have a lot of logic in it. You might want to use things like, not Sphinx, sorry, the other way around. Sphinx sucks. And I forgot the name of technology, but basically, very popular Spark, no? No, Algolia is a service, right? No, I'm talking about the, anyway, I'll try to find it if anyone is interested, but basically the idea is that you don't generate HTML output. The system keeps all its indexes like any search engine would do, but it will keep indexes in memory, right? So and it will reshuffle the output based on that. So it is data driven, but it's much closer to static generation than people think, right? It does calculation on indexing stage, not in real-time request. No, Google doesn't go and search for your document in the world, right? It does indexing and keeps the results, right? So search is kind of one of those things where personalization is so narrow that you might not want to, might not be able to do it. But hopefully you're not building a search engine, so search is not your primary function, right? Or at least it can be a very important function, but it's not the only function. More importantly, search engines don't care, by the way, right? About your search engine, right? They don't need to index the results of your search engine, right? Your users can be, your interface for search can be created in a way that is useful before search result comes back, and you know, it can be well optimized. And then I think you're done. Then you build your dynamic generation, build this event or whatever like trigger system that triggers incremental builds, and make your users happy because they will experience speed, buy more ads, no, click more ads, what is it? Buy more products, whatever drives you, right? Do more good, whatever that business metric is. So let's do that, and whoever does it first can make a presentation at this meetup, and we'll do a joint session with Web Performance Meetup too, right? Right? Yes. So perfect. So thank you. Do we have time for any questions? Couple minutes, couple questions. Anyone?
So what are the most popular, I guess, frameworks or libraries to organize this whole workflow? Are there any?
Well, this is the first time the word dynamic generation was used in the public. I'm kidding, not really. I think streaming setup is probably your common, like Kinesis, or there are Kafkas of the world. I'm actually not a streaming professional. I don't know enough of that. So for streaming, for that event process, in fact, they have a even concept called CQRS, which is basically static generation, kind of generate the output, basically write data for storage separately from your read data, basically generate the output. And you just need to extend it from generating the JSON or database entry to generating HTML, because in the end it's the same, right? What else in there? Well, maybe this GraphQL approach with subscriptions can work. You know, otherwise it's the same technologies, and there's nothing magical, right? Serverless, right? Like technologies are there, right? The question is, how do you trigger that in? I think one core concept of distributed systems and systems that can act on any type of data in any kind of way is small granularity, right? The moment you create small granular things, like with serverless, for example, and it ends up processed in the output, I think that's the key here. So not those long-running lambdas, right? But those incremental lambdas, like in our system. One was listening for the data change, generated the key for input. That one was picked up by another lambda, determined the fanning out, that dependency management, right? Which ones need to be updated, saved that into another queue, and that generator from the queue went and just hit the website for those URLs, saved them to the files, and that's it, right? So the moment, I think this approach is probably a good approach to follow. Thank you.
Thanks. Do you know if there are any, like this looks like the main use case that you've seen this used for in your own experience is like you have a dynamic site, you're using it to basically pre-generate a bunch of cached, you know, and whatever pages or
pre-generated, not cached.
Yeah, so it's pre-generating by essentially like hitting an origin when this event happens, right? So
hitting an origin is an easy implementation. It doesn't have to be that way at all.
So
it
I guess
can be
my question
similar
is,
to static generators.
Do you know of any static generators, or have you seen, you know, this approach start, like for example, incremental builds on static generators? Like what's doing that well? What are some tools that are starting to solve that problem?
None that I know of. In 2 words, right? Nothing follows this for universal data source. There are some optimizations, right? Every static generator today can probably optimize determining the outputs based on the input, right? And only build those, right? Using the very same flow for events, right? Like Git update, they can determine which ones I need to regenerate, which ones I don't, right? It can be done for this small ecosystem, but nothing uses this universal, like I don't care what I regenerate, right? Where data came from. And that is something what I'm proposing to build. Let's build it. Nothing magical, just need to do it. And this way we will be able to statically or dynamically generate every single website out there. Every single one. It doesn't matter if it's a data from your own business that comes at weird places, or if it's user-generated data. You can generate any data, right? They enter a comment, go the flow, post it. Some services actually do that already as a third-party services, right? But it can be anything. Rankings, content submissions, anything, right? That's the whole goal. Speed up the world. Okay, seems obvious. Let's do it. Thank you.
Thank you, Sergey. I will mention that Gatsby's working on that specific problem, though it's what Sergey proposes that we do this for everything. Gatsby's doing it just for static sites. So they plan on releasing something this year. So we'll see how that goes. Thank you very much, Sergey. Really appreciate it. That was a fascinating talk. Thank you, Jared from Serverless. That was also fascinating. Thank you, everybody, for coming out and being part of JAMstack. Please come to thenewdynamic.org, join our community, read the articles, and chat with us. Awesome. Bud, do you have anything to say?